guys, welcome back. So what we're looking at today is 6.4, a leap year. So let's go ahead and jump right in. All right, so what we're looking at here is defining polygons and their attributes. So for each of the geometric words below, write a definition of the object that addresses the essential elements. So a quadrilateral, cannot talk, is a four-sided polygon. That's its key feature. It's got four sides. It's a polygon, which means it's closed. So that's what we know about quadrilaterals. A parallelogram is a quadrilateral. With two sets of parallel sides. Now, a rectangle, make sure you include that as quadrilateral, and then explain what else is important about it. What do you know? Then a square, same thing. So all of these are going to be considered quadrilaterals, and then explain from that what is specific to them. So like rectangle, four right angles, square, four right angles, and four equal sides, rhombus, four equal sides, trapezoid, one set of parallel sides. So all those different things, explain those out in your definition. All right, the next section is looking at reflections, rotations, composing reflections to create a rotation. So for this, we want to use the center of rotation C and rotate point P clockwise around it 90 degrees. Label the image P prime with point C as a center of rotation. Also, rotate point P 180 degrees. Label this image P double prime. So the one we're actually going to do first is the P double prime. So if it's a 180 degree rotation, that means P, C, and P double prime are all going to lie on the same line. So with that being said, we just see what the slope is. So we went down 1 and over 1, 2, 3, 4. So we go down 1 and we go over 1, 2, 3, 4. So that point right there is our P double prime. So P double prime is the point 2, 0. Now, for P prime, remember, if we want it to make a right angle, we're going 90 degrees. That means we want the line that P and C are on to be perpendicular to the line that C and P prime are on. So we just said our slope here was down 1 and over 1, 2, 3, 4. So we've got negative 1/4 slope. Opposite reciprocal would be positive 4. So from C, we're going to go up 1, 2, 3, 4, and over 1. Right there is our P prime. So P prime is the point -1, 5. So that's what you can do when your rotations are about a point other than the origin, especially 90 and 180. 270, we just take it the other direction. We'd go down and over instead of going up and over. But yeah. All right, so it's the same idea for number 8. You're going to do a rotation, 90 degrees, and then 180. Now, for 9, 10, and 11, these are a little different. These we're looking at what is the line of reflection to take in math these. So we're actually finding how it's reflected. So for 9, what is the equation for the line of reflection that reflects point P onto P prime? Well, to go from P to P prime, what's the line halfway between? Well, it's the line x equals 0 or the y-axis. Now, what takes P prime onto P double prime? Well, halfway between, it's the x-axis or y equals 0. Now, could P double prime also be considered a rotation of point P? If so, what is the center of rotation and how many degrees was point P rotated? So notice P and P prime. They lie in the same line, which means it's a 180 degree rotation about the origin. So same idea for 10 and 11, but for these, you're going to actually have to come up with the equations. So it'll be a little bit more complex. So I'm going to do at least part of 10 with you. So for this first part, what's the equation for the line of reflection that reflects P onto P prime? So from P to P prime, well, here it's not going to be an axis. So we look at what's the slope. So down 1, 2 over 1, 2, 3, 4. So we're down 2 over 4. So we have a negative 1/2 slope between them. So the line of reflection will have a positive 2 slope starting from this point right here. Make that bigger. It's easier to see. And so then go up 2 over 1. This is our line of reflection that I'm drawing in right here. And so we extend it out so we can see what the y-intercept would be. And it looks like the y-intercept is going to be at -2. So the equation for the line of reflection would be y equals 2x minus 2. So that's what the same thing that you're going to do for 11. Now for part B on this one, what's the equation for the line that reflects P on or P prime onto P double prime? Well, once again, it's y equals 0 for the x axis. And then lastly, you'll figure out what that rotation is. So I'm going to leave that one for you so you have a few more to think through. All right. The last section is all about rotation. So we've had a lot of rotations here. Rotation is your key word for this lesson. Now, rotations about the origin are nice because there are rules for doing them that will work every time no matter what. So if we have a clockwise rotation about the origin, now this is only about the origin, 90 degrees clockwise, we have our given coordinates x, y. The new coordinate after the rotation will be in the form y negative x, which means we're flipping our x and y and changing the sign on the original x value. Now a 180-degree rotation, same thing, we've got our point. All that happens here is we change the signs. Now, negative x, negative y does not mean you automatically make x and y both negative. It means you change the signs on them. Change the signs on them. And then 270 is going to be negative y x. Now, these are all clockwise rotations. Counterclockwise are essentially the exact same thing, except the 90 and 270 get switched. 180 remains 100% the same, but 90 and 270 switch. So in counterclockwise, this would be 270 and this would be 90. So keep that in mind. All right, so we want to plot the given coordinate and then perform the indicated rotation in a clockwise direction around the origin, the point 0, 0, and plot the image created. State the coordinates of the image. So we're going to go ahead and do 13, point B. So we've got the point 5, or negative 5, negative 3. So negative 5, 1, 2, 3, 4, 5, negative 3, 1, 2, 3. There's our point B. Now, to do the 90-degree clockwise rotation, so let's look, 90-degree clockwise rotation, our coordinate is negative 5, negative 3. So here's our x value. It's going to become our y value, and we have to change the sign on it. So it's going to be positive 5. And then our y coordinate will keep the same sign, and it'll be negative 3. So our new coordinate is negative 3, 5. So we come back down here, and we're going to plot b prime at negative 3, 5. So 1, 2, 3, 1, 2, 3, 4, 5. So there is our b prime. So that's what you guys are going to do for 12, 14, and 15. So 12 and 14 are both 180-degree rotations. 15 is 90-degree again, okay? All right, if you guys have any questions, feel free to ask. Have a great day.